Today we're going to start section 5.2, which is on area and sigma notation. Please fill in your notes as you go. This notation right here represents what we're doing is summing n number of terms. We call this summation. Now you should know each part, each part of this notation here. So the index of the summation is the lowercase I in this one. The ith term of the sum is ai. The upper bound is n, and the lower bound is 1. The lower bound does not always have to equal 1. Answer a few questions. Back to the notes. Let's find the following sums. What this means is we're going to plug the number 1 into I, and we're going to keep plugging numbers up until you get to the upper bound 6, and we're going to sum those numbers. So we plug 1 in for I and we get 1. Now let's plug in 2 for I. Then plug 3 in for I. Plug 4, and you keep plugging in until we get to the upper bound of 6. And then you can add these together in your calculator or in your head and get an answer of 21. Let's look at B. We're going to start with 0 and keep plugging in integers until you get to 5. So let's first plug 0 in for I. So I get 0 plus 1. Add that to the next term, which will be 1 plus 1. Add that to the next term, 2 plus 1, and so on. We can then add each of these terms up and get our total sum of 21 again. Let's look at C. We're going to plug 3 up until 7 for J. Plug 3 in for J, I get 3 squared. Add that to the next term, 4 squared. To the next term, 5 squared, and so on. I'm going to then tally or compute this and get a total of 135. For the last one, we're going to plug 1 in, not for n, but for k. So I'm going to plug 1 in, and then I'm going to continue. My next term, I'm going to plug in 2, and then you're going to plug in 3 and 4 and 5, and you're going to continue until the last term. The last term we plug in the upper bound, which is n. And I can't actually total that. Let's do some practice. Next, there are some basic rules. You're probably familiar. When I have a coefficient, I could pull the coefficient out, find the sum without the coefficient, and then multiply it back. Also, if I have a polynomial, I can sum each piece of the polynomial. Find the sum of each piece and then add them up. Next, there's some basic formulas that you must memorize. Be prepared for a pop quiz within the next few days on these formulas only. If you're summing the numbers from 1 to n of just C, your answer will be Cn. For I, the answer will be n plus 1 over 2. These are basically shortcut formulas that you can use to find the sum. I squared, we're going to use n times n plus 1 times 2n plus 1, all divided by 6. And I cubed, if you see I cubed, instead of having to add up each sum, your shortcut is n squared, n plus 1 squared, all divided by 4. Practice the formulas. Let's try using those formulas to do an example. Before we do example 6, let's squish an example right here. Let's try doing the sum of 1 to 20 of 2i. Now, we can pull the 2 out because it's like a coefficient, and we're still going to find the sum from 1 to 20 now of just I. So we have the 2 carrying along. The formula for I is n times n plus 1 all over 2 that you will have memorized. Now we can simplify this. The 2's can reduce, and we just have n times n plus 1. And then we can plug in our n, which is our top upper bound number. So 20 times 21, and get a final answer of 420. And that's much simpler than adding the numbers, the 20 terms up from 1 to 20. Alright, for example 6, we're first going to try it as if n were 10, or even if n was any different number. We're going to kind of do this similarly. We can only use the memorized formulas that we know, which all include I. Right now, n is a coefficient, so I can pull that coefficient out, pull the n squared out. It's actually 1 over n squared. Now I'm left with I plus 1. Now we have a formula for I and we have a formula for 1. So let's use those two formulas. What we're basically doing is summing each piece. We're going to sum the I and then sum the 1. So the formula for the sum of I is n times n plus 1 all over 2. And the formula for 1 is just n, 1n. Now we want to clean this up. So there's more than one way to clean this up. If you want to work inside the brackets first, we can make this have the same denominator so that you can add these two together. And you might want to FOIL this and get n squared plus n. So now that I have the same denominators, I can add n squared plus n plus the 2n and get n squared plus 3n on the inside brackets. On the outside I have n squared. What I could do is factor out the numerator and get n times n plus 3. And this n can cancel with one of the n's out here. So I'm left with n plus 3 over this n times 2. So this would be my simplified formula, n plus 3 over 2n. And then I can plug in whatever they want. If n is 10, I can then plug in and get 10 plus 3 over 10 times 2 and get 13/20ths. If n were 100, I can do the same thing. I get 103 over 200. And so on. If n were 1,000, I would get 1,003 over 2,000. And 10,003 over 20,000. Let's do some more practicing. So what you want to do here is for I cubed, write the formula for I cubed, and then you can plug in the 10. So I have n squared, n plus 1 squared over 4 is the I cubed formula, and then go back and plug the 10 in everywhere. For this one, I could pull the 2 out. Then I could do 2 times the I formula. And the I formula is n plus 1 times 2. The 2's can actually cancel, and then just plug in the 20. For this one, I can do the sum of I plus the sum of 5. The I formula. This is like C, so this would be Cn or 5n. And then you can plug in 10 for n. Next, let's figure out the limit. The limit as n goes to infinity. So think about it. As you go far off to infinity, it's like finding the HA. So you're doing the same HA rules. Notice the powers of n are the same, so the HA would be the coefficients, or 1/2. So when you're finding the limit, when you go to infinity, it's the same as the HA rules. Let's practice. What would your answer be to this problem here? Next. Last thing you want to do is you can check all of your answers by using the calculator to figure out the summation. Now many of you probably have maybe an 84 plus at home. If you do, then you can press the Math 0 button and hopefully you can find the summation. If you're using my Inspire calculator in class, you can press the menu, calculus, and then press 3 and fill in accordingly. If you have an older calculator like an 83 or 84, try these buttons. Hopefully I have them correct here. Second, then list, then math, then you're going to hit 5, second, list, ops, and 5. And then hit sum, or what it should look like, it'll say sum, and then it'll say sequence, and then you'll have to open a parentheses, put your function in using variable x from the lower bound to the upper bound, and then close your parentheses and you'll get your answer. So if you try it out in your calculator, hopefully you'll get the correct answer of 35. And we're going to stop here for today.